Alright, welcome back to Meteorology 101. I'm going to look at this weather system pushing through. We're going to check out the satellite, radar, surface chart. Maybe go up into the upper levels a little bit, not too much, and then take a look at the models and see what's going on. So right now, we want to get a look at the satellite, and we can just kind of get an overall overview of this thing, see what's going on with the satellite, and try to place our systems through that. So right now I'm looking at flow to the south, long wave trough. I would place a jet stream right here, pushing all the way up through. It doesn't have to be behind that cloud layer. It can just be right through it for the jet stream. So there's our jet support for what I would say is a frontal system right through here, and long wave trough, a little bit of low clouds in these brighter blue areas. So if we look at this, we can see a southerly flow right here, so putting moisture up into the Gulf region, clearing right through there on the east coast, a lot of low level clouds all through the North Atlantic and New England states, so and over the Great Lakes region. Now I would look for, on this thing being that deep of a trough, I would look for this jet stream to not be able to make that turn much longer and create a cutoff low. So we have a low pressure system right there, left sitting right there. And then if we look over Texas, we have some low level clouds there. If we watch the rotation on those, we can actually see pushing to the north. You can almost see a rotation over Texas. We have to get a better look at that on a chart. And then high pressure, I would say, off the east coast. Maybe even right through here. It's causing these low-level clouds. Probably a lot of fog through this area, and then just a lot of low-level clouds. You can see those streaks right there. So we got high pressure probably originating right through here. Let's see if there's a low there. We'll check out maybe a high to the north, and then the low well to the north with a frontal system. So we'll have to see how that ties into this low. But I'm looking at the jet stream being right there, so that's why I would say the cold front's here. Turn that back on. Click, click, click. Okay. Cold front's right there. This high pressure system here, if we had a warm front, we probably got an occlusion up here, then the warm front dropping down. Let's see what's going on there. But you got the cold front ahead of this high, the jet stream behind that cold front supporting that low pressure system, and then we'll have to see what kind of low pressure system is developing over Texas. So maybe some low level clouds and snowfall in the upper elevations over the Rockies. So that's pretty much the initial look at satellite. So let's go to the radar. Right, here's the national radar. Alright, so like we said, cold front. Now, placement in this front, I would say it's a slow-moving cold front. Low pressure system well to the north. I don't see anything over Texas. I see that southerly flow we were looking at on the satellite, pushing that moist air off the Gulf. So that's kind of feeding this system with moisture. As this frontal system pushes down, it's going to collide with that moisture and create some significant weather there. We have our long wave trough that was over the southwest, and then right ahead of that trough, we have some significant weather south of the Four Corners. All right, so if I had to, let's say, a low pressure system up in Canada, bring probably an occluded front out of that. That should be purple, and then bring that other front down into Texas. I would The cold front I would bring down in Texas just because I would leave that weather behind that front because, like I said, I think this is a slow-moving system. The cold front's a slow-moving cold front, so all your weather be a shallow slope, and all your weather's going to be at and behind the front. So outside of all this moisture onshore flow from this high-pressure system, bringing all that moisture up off the Gulf. So then that's interacting with a little bit of instability and creating precip from Louisiana up into Arkansas. So looking at satellite, looking at radar, they match up. We got, I would say that's where our frontal system is. This is the frontal system that's going to, basically this load's going to push to the east. The frontal system's going to drop down, and we're going to have that significant weather all the way from Texas up into New York. We have a whole area of just snow, freezing rain, mixture, pretty much any precipitation you can think of with the mixed precipitation. We'll have to look at our 540 line. We'll pull a thickness chart and see where that 540 decameter line is, and then that will give us our rain snow line, which we know right now it's right here. But as it pushes south, then we know all this rain, as that cold air pushes south, then a lot of that precip is going to push south with it and then become mixed or frozen into snow. Alright, so we pretty much laid out the radar. Let's go to the weather charts. Alright, so right now we are on the surface. We're going to pull sea level pressure. Like I said, the low pressure system is well north into Canada. We have that low pressure system over Texas. We have to keep an eye on that. If our frontal system comes down into that low, which there's the inverted trough, that's where our frontal system would lie, right in that trough. Right out of this trough into this trough and then right into that low. So it kind of makes sense, separating these two high pressure systems. Now, not a whole lot going on over Illinois as far as advection, but we do have that frontal system causing our lift, so we do have significant weather over there. We've seen that on the satellite and the radar. So we have that high pressure system to the northwest, north of Montana. High there, low there, and I would say probably an occluded front right here. So let's get this to the right color, and then I'll pull the isotherms. We're going to pull the isotherms, see where that occlusion lies. We got cold front probably coming down into this low pressure system. Now, probably not that deep. I would pull it down into here because we know the winds around the low are counterclockwise, so we have thermal advection. Let me turn that off for a second. Let me get the isotherms on here. These are lines of equal temperature, so now we can see where our thermal advection is. And now if we look at that, we can see right there we have warm air advection. So we got a warm front right out of that low. Okay, our thermal ridge is right here. I don't want to make too much of a mess. Alright, so I'll probably bring that over east just a little bit and then bring it back. And that's messy. And then we'll bring our cold front see, we'd want to bring the cold front down to hook up with that low pressure system. It kind of makes sense with the radar and the satellite and the jet stream. So we can't pull this thing, we can't pull it too far to the west. So you kind of want to tie those together. Pretty short cold front right there. I think this thing's kind of a slow moving front. That's why we got all that weather at and behind the front. So we got to look for this low pressure system. It's got to be a slow moving front just because low pressure system developing on the tail end of that front. And it's actually got thermal advection associated with it. Not a whole lot of cold air advection on the backside, but it's got a little bit of warm air advection there. So you can almost, keep that stationary. It's not really moving on the tail end. So let me erase this. So we can almost bring a cold front down. We know it becomes stationary in this zone right here because there's really no thermal advection. So you have a occluded front, cold front, really no, basically stationary front, and then a little bit of a warm air advection there. So all tying together in that one area. So that's what makes this system pretty significant. Plus this thermal packing is very tight. So any thermal advection that we do have, the cold air advection, that's some pretty strong thermal advection right there. The warm air advection, well to the northeast, that's a pretty good gradient too. And we have a pretty deep, we have a build up thermal ridge right there. That's a pretty strong ridge too for a thermal ridge. So a lot of significant weather with this mature low that's to the north. We can associate with this system. So bring our front down through here. Our jet stream, like I said, was with that long wave trough. Jet stream up, crossing the triple point, supporting that low pressure system to the north. So the jet stream can't cross the cold front. It's going to have to cross the occluded front and pretty much stay to the north over that low. Now, like I said, with this type of thermal packing, our significant weather is going to be at and behind that front. So you can pretty much place all that right through here for now. And that's pretty much what we've seen on radar. As we watch this cold front drop down, watch that low pressure system move to the east. We got this cold front going to move to the east. Now what happens with the tail of this cold front depends on this high pressure system. Is it going to allow this low pressure system to develop and ride up that front? Probably not. It's probably going to ridge in too fast. So this front's probably just going to stall out. This high pressure system is going to move in, become deeper into the south, and now this low pressure system will just sit there, but that cold front will become more stationary as that low pressure system moves to the east. This northern part of that front is going to continue to move, at a decent rate, and then the tail end of that front is just going to sit there. Now, what happens to that low? We'll have to look at the models. It may just fill in from this high pressure system ridging in, because we know we get that cold temperature drop this week, and all that significant weather Thursday and Friday. We got a mixture coming all the way from Texas all the way through up into New York. So we have a mixture of snow, rain, freezing rain, ice pellets, any kind of mixed precipitation all through that area. So we'll look at the models, get a good look into that real quick. Okay, so we're going to pull the station plots real quick, and then we can pretty much determine off some of these stations. This stuff's within the last hour. It's been downloaded within the last hour. So we got there's a new update coming out for the hourly observations. But if we look at this data, we can place our fronts, see where those high pressure systems are. That's where these isobars, the lines of equal pressure, that's how it's analyzed from these station plots. So all this data, isotherms are plotted with these temperatures. The top number is the temperature, low number is the dew point. So that's how the isotherms are plotted. The top right, 3 digits, are the pressure, station pressure. So that's how these isobars, the lines of equal pressure, are analyzed. So, and then that's how we determine where the lows and highs are. This is all computer generated. Kind of goes closest to the station. That makes more sense. But if this thing was 100% accurate, you would see lines like this, like you do on those on the forecast models. The forecast models they're they try to be more accurate, but I don't really look at them for station pressure too much. I mean, I look at for the lows, how the low's developing. First, you got to initialize them. You got to verify them off of something. These real live data charts where these low pressure systems are located. What are the low pressure centers? That's what you're going to verify the models from, how they are initializing, if they're going to do a good job or not. So I see a lot of people chasing the models, but they never pull a surface chart to verify those models, how they're initializing, and if they're going to pan out. So if they're starting wrong, they're going to probably end wrong. So these real data surface charts, upper air charts are very important to weather forecasting. I just see a lot of people ignoring them. So not really meteorologists, just enthusiasts more than anything. So, which that's fine. Everybody does it their own way. All right. So, what I'm looking for is temperatures. There's a 38. Pretty much made a mark on there. I can't see my temperature. Is 52, 26, 38. So we're dropping right there, going into that cold air. 10. Alright, we got a wind out of the northwest, wind out of the southwest, so there, that front's going to be right in that area somewhere. And then you can see the winds are out of the northeast here, all the way through, and then we start getting this rotation around this low. You can actually verify rotation with that low. I'd probably bring that low a little bit over. There's one little westerly flow right there. It's a 5-knot wind. I would ignore that, just because it's a 5-knot wind and it's out of place. So when you get a 5-knot wind out of place, you can go anything up to 6 knots. You can go variable. So you can pretty much, for this to become a sustained wind, it was in that direction most of the time. So the ASOS pretty much said that is a sustained wind out of the west at 5 knots, which, okay, ignore it. You have a 10-knot wind from the southeast, 10-knot wind from the north, 10-knot wind from the northwest, and then it looks like maybe just a 5-knot wind from the southwest, and then you got the southerly flow, which we know that's all true. So there's a rotation around that low. All right, looking at temperatures, dew points, you got a dew point of 17, dew point of 9. Temperature of 20, I think I said 26, that one's 17. So right there is where the cold front is. So we're dry air behind it, warmer, moist air ahead of it. It's obviously not warm, it's in the teens. There's a 38, there's a 54, so there's your warm sector. Winds are going to be out of the southwest in your warm sector. All right, so warm, moist air. We see a lot of the cloud cover here. Overcast. It's all overcast. Now, these red dots are IFR conditions. That's for aircraft. Your visibility's dropped below 3 miles. Where your ceilings drop below 1,000 feet. So you have low ceilings, which this one's ceiling is 1,600 feet. Visibility is only 2.5 miles. So that's why it's red, because of the visibility. We have moderate rain right in that area. You can see by the symbol. That has light snow, light rain. So as we catch these on the hour for the precip, then you will see those a lot of those stations that are plotted. They'll put the precip types in there. So, all right, that's pretty much it for the surface chart. All right, let's take a look at the models. So we know we got that low pressure system well to the north. We got that troughing down into the Great Lakes region, which just is accurate. Then we have that, it's kind of a low pressure system over Texas. And then we did have that inverted trough there. So we were kind of tying these fronts together. And then right along that front, at and behind that front was all that precip. So this is a GFS. This one seems to be initializing pretty well. We did have some frozen precip over Colorado, a little bit to the northwest. We did have a little bit more precip than what this is showing. So in the southwest, this is a 3-hour forecast right here, valid for 21Z. Actually, this is a little bit old data, so Let's go forward to the 0Z. That gets us about an hour ago. And then we can start seeing that mixed precip over northern Missouri. So there's a low pressure system, pretty tight gradient. This is more or less a thickness chart. So we're looking at that 540 line. So you can see where the lines go from red to blue. The 5,400 meter line, we can see where that crosses. That's going to go through this mixture and then come back out. And then it looks like it drops down and then off the Atlantic. So this is the mixture. That's the mixture line. Rain snow mix line that we're going to see come through the Ohio Valley, pretty much all the way through from Texas all the way up into New York. So let's see how this progresses. And I mean, right now it's initializing pretty well. We're a couple of days out, so it does look pretty good. So like I said, you know, it looks like it was a slow moving cold front to me. So the low pressure system well to the north, you can see that thing moving to the east, which is moving pretty slow, and then we start getting this cold front pushing to the south. That high pressure system ridging in behind that front, and then undercutting all that warmer moist air, and then that southerly flow off the Gulf states colliding with all that moisture. So now we got purple, red, the blue snow. We got freezing rain, and then ice pellets, rain snow mix in there too. So, and like I said, right there, stretching all the way from New York all the way down into Texas. So that's pretty much what is going to occur. So now if we look at this thing, you know, if you look at your, wherever you live along that line, like I'm in the Ohio Valley, so if we look at Southwest Ohio, then we can see we start off with rain, and then we get out to about 21Z. It's about 4 p.m. 7 p.m. 10, and then 1 o'clock in the morning overnight. Now we're starting to get into that mix, and that's freezing rain, ice pellets, and then we pretty much stay in that for the majority of the storm. And we got 03Z on Friday, so that'll be Thursday evening. Late Thursday evening, we're pushing in the snow. We coat snow over top of that, and then a little bit more snow coming through if that's the case. I mean, this thing's breaking up, you know, so that snow could last longer. It could go shorter up into Friday. So looks like Thursday and Friday are going to be pretty much hazardous conditions all the way through these areas. So now the problem that's we're going to have is, especially now down in Texas, we've seen what happened last year when we had that cold air push through, or 2020 when that power went out. That's pretty much what we're going to have all along all these states where you see that red and that purple. If you're getting that much freezing rain and icing, then you can pretty much bet there's some power lines coming down. So power outages from Texas all the way up into New York. So if you have a generator, get it out, start it, warm it up, get that thing prepped, and make sure you got plenty of gas on hand. I would do that tomorrow before this thing shows up here on Thursday. So some of these states you're already gonna be pushing up for Wednesday, like northern Arkansas, southern Missouri. Here's 12Z Wednesday, 7 a.m. You're already into the mixture, so pretty much need to be on top of this already. All right, so that's pretty much the models. I don't really trust the models 100%. Like I said, you got to see where them low pressure systems are and what's happening before you can verify these models. I mean, these are initializing pretty well, only 2 days out. I mean, you get people look at them 5 days out, but and then they obviously change every time. So you get these guys on YouTube and stuff, they'll sit there and chase these models out tell you all this stuff's going to happen, and then 2 days later everything dies out on the models, and then it's just not there. So take the models with a grain of salt. Look at the charts. That's what you're going to want to look at. That's going to give you the answer of what's actually happening. So I can say, just by looking at this data, we have our highs, we have our lows, and we have our station plots. These station plots are real-time data. So when we look at these winds rotating around these lows, we can verify the position of that low. We can look at these pressures. You got 1007.1 millibars. We got 1002 millibar low. So we're pretty close right there. There's 1008.2, 1004.5. So I would bring this a little bit more to the west and drop it down to the south. Now you got your rotation right in this area. That's where the low is. So the computer was even wrong. So once you learn how to read these station plots, then you can place that low. Now how deep that low is, being 1002 millibar, we got 1004 millibar right there, 1007, 1008, 1004.8, 1004.5, going down to 1002 millibar low. That's acceptable, 2 millibars, just to place it right there in the center of Texas. So same thing with your fronts. Look for the temperature differences. 38 to 26. That's a pretty good temperature drop. Dew point's 33. Dew point 17. You got a wind shift from the northwest to the southwest. Now you can place that front right there, right between them two stations. Okay, so that's the stuff you're looking for to place those. Now, when you go over to the models, then you can try to see where the troughs are, and then it doesn't give you station plots, so that's killing you there. But you look at where the trough is, what's the placement of the lows, and then verify that model run, is initializing well. So you can say, hey, that's a model I want to go with to trust more. So, all right, if you like something, give me a thumbs up. Visit my website, meteorology101.com. A lot of information on there. I'm going to start doing some more educational videos. Try to keep some stuff short. Cover that website. I might just hit the website, read a paragraph, and then we can explain it and break it down for you. So subscribe to the channel and stay tuned for more. Until then, keep your head in the clouds.